Hi everyone, welcome to PrepFusion. So first, before starting this video, let me tell you who should watch this video. So if you are someone who has never studied EMFT, if you are someone who has no idea of EMFT, still you can watch this video. By the end of the session, you will be much comfortable for 2 to 3 marks in your final examination. Okay. Now you would be saying that, sir, I shouldn't be learning anything new, but you can learn it. Here I will just tell you a problem solving skill, that how you can solve the problem in the examination from these particular concept, because these are very high yield topics. There is 90% chances are there that from these topics question will be framed, and if you watch this video with good amount of patience, then by the end of the lecture you will be much comfortable in solving those problems in the examination. So here, as decent problem solving skills, I will tell you a decent problem solving skill we are going to develop, and that will help you a lot in the examination. So if you have completely skipped the subject, then you can watch this video. Secondly, the guy who is not comfortable with this particular topic, like you would be comfortable with impedance, I guess, but if you have someone who has studied EMFT and still you would not be that comfortable with standing wave pattern, right? If you are someone who has studied EMFT, then I know that standing wave pattern is one of the topic where all the gate aspirants struggle. So that particular topic also we are going to see, and a very good problem solving skills we are going to develop. And no single formula I'm going to apply there. In standing wave pattern, there will not be any single formula. I will just tell you a way of solving a problem. Okay. And that would be very intuitive. You will like that particular concept a lot. So just hold on to the video. Just watch it till the end. So now we are going to start the video. But before that, I will take a pause and then I will start. Yeah, so let's start. So first we need to study some wave parameters. Before going into the concept, first we need to study some wave parameters. So you know what is a wave? You must have heard the word light wave, sound wave. This is a wave, right? So what is the velocity of a wave? Let's just say it is light wave only. So what is the velocity of light in free space or in air? It is equals to the speed of light, which is equals to c, 3 into 10 to the power 8 meter per second. But if it is traveling in a particular medium having dielectric constant of epsilon r, then what is the velocity? That is equals to c divided by under root epsilon r. The velocity reduces. This is the maximum velocity it can have. If it is traveling in a particular dielectric medium, then velocity will reduce. These things you have studied in elementary classes. So I hope you remember it. If you don't remember it, then you can learn it now. The velocity, actual velocity is c upon under root epsilon r. For free space, epsilon r is equals to 1. For air or for free space, epsilon r is equals to 1. So the velocity becomes equals to c only. One thing, okay. The second one, there is a term called wavelength. So wavelength, what is the formula of wavelength? Lambda is equals to Vp by f, velocity divided by the frequency. F, frequency of what? Frequency of wave. F is the frequency of wave. Are you getting this point? So lambda is equals to Vp by f. This formula also you need to remember. I hope you would have studied f equals to Vp by lambda. Usually we remember this formula. In 12th class, you would have studied this formula. F equals to Vp by lambda. So now you can see lambda is equals to Vp by f. So this is one formula you need to remember. And then there is something called phase constant. So formula of phase constant is 2 pi by lambda. So just these things you need to remember. I am not going deeper into the concept that from where this formula came, what is the meaning of this formula. That concept we are not going to see. So if you are just watching this video, then these much things you need to know first. Velocity of wave in air, c. In a particular dielectric medium having dielectric constant of epsilon r, that would be c upon under root epsilon r. Wavelength, the relation between wavelength and the frequency of wave, that is lambda equals to Vp by f. And what is the phase constant? That is beta, which is equals to 2 pi by lambda. So beta, lambda and Vp, these things, basically we have seen the relation between Vp, beta, lambda and f. So just see this slide and try remembering these terms. Even if you forget it, by the end of the video you will be remembering it, because we are going to use it again and again. Okay, let's start our topic now. So impedance on transmission line, this is our topic. So what is the transmission line first? So transmission line is nothing but these are two wires only. Have we seen these kind of wires? Yes, in network analysis we have seen these kind of wires. So what do we do with these kind of wires in network analysis? Here let's just say I connect a resistance R. I am calling it a load. What I am doing, I am connecting a resistance R. So here also what I will do, I will connect a load. Just one sec. Yeah, so what I was saying, in network analysis, this was my, wire. At the load of the wire, I am connecting a resistance R. So here also these are two wires only. But this wire and this wire both are different. What is the difference? That I will tell you. So here also I am collecting a load. That load I am calling as ZL. This is ZL load I am connecting. So here at the end of the transmission line, I have connected a load. Okay. In this particular network analysis, what do? Here we give a supply. We apply a voltage source, right? It could be like it could be AC source as well. It could be DC as well. It could be step as well. It could be anything. Like here in place of this, I can apply AC source as well. So here also I will do the same thing. I will apply a source. So there are two wire. These two wires are known as transmission line. What I am doing, I am applying a source at the input side, and at the load side I am connecting a load, that is ZL. Is that clear? Very simple thing. Now in this particular question, if this question is from network analysis, if I ask you what is the input impedance looking from here, what is the impedance looking from here, what you will say? Sir, R only. Now next question I ask you, what is the impedance looking from here, what you will say? Sir, R only. What is the impedance looking from here? Sir, it is always R only. But that is not the case with transmission line. In transmission line, at every point impedance changes. If I ask you what is the impedance looking here, basically if I ask you what is the impedance looking here, right here I am asking, then you will say, sir, it is ZL. But what if I start working on transmission line? I am starting working on transmission line. That means if I ask you the impedance here, what you will say? What will be the impedance? You cannot say, sir, it will be ZL. Here if I ask you what is the impedance, you will say, sir, it is R only. Because these wire has nothing to do. But if it is a transmission line, then you cannot say the impedance will be ZL. It will be something else. Okay. So what that impedance would be? These kind of questions are asked. So let's what I'm going to do is that, let's just say the length of this transmission line is L. Okay. Then there is a term characteristics impedance. Characteristic impedance. So for all the transmission line, characteristics impedance are defined. That is known as Z0. Like for a different transmission line, characteristics impedance value could be 50 ohm. For some it could be 70 ohm. For some it could be 80 ohm. So just remember that it is just a characteristic of your transmission line. Whatever the transmission line is given, the characteristics of that transmission line is defined by its characteristics impedance, that is Z0. For different kind of transmission line, it could be different. Now there are two wires, no? One wire and another wire. So between the wire there could be any medium. It could be air as well, it could be water as well, it could be glass as well. Between the wires there could be any medium, and that medium can have its dielectric constant. So epsilon r. Don't feel like that, sir, there are too much information. There is nothing. Two wires are connected. At the load you are having ZL. You are applying a voltage source Vs. That's it. And from where you are starting? Now I will start working from the load. Whatever the analysis we are going to do in transmission line, we will do from the load only. Okay. So this is my y equals to 0. What I am saying, this is my y equals to 0. So what this will be? Y equals to L. So if I am at load, then my impedance is ZL. But if I am y distance away from the load, if I am y distance away from the load, if I am someone who is here, if I am y distance away from the load, then what will be the value of my impedance? What will be ZY? So that ZY is given as Z0 into ZL plus JZ0 tan beta Y. Now, like, don't get afraid that, sir, how we will remember the formula. Slowly you will remember. Just watch the video till the end. After that you will be very comfortable. But don't give up in between. Okay. So this will be the formula. What is the formula? Getting started with Z0 into ZL plus JZ0 tan beta Y upon Z0 plus JZL tan beta Y. This will be the formula. Even if you forget it, then also there is very high chance that you will be able to solve the problems. Okay. But eventually you are going to remember it, because I am going to write down this formula again and again. Look, there is symmetry. Getting started with Z0, then ZL plus JZ0 tan beta L. Then in the downward, here you are having ZL. So now you are having Z0 plus J. Here you are having Z0, you are having ZL tan beta Y. Okay. Z naught into ZL plus J Z naught tan beta y divided by Z naught plus J ZL tan beta y. What is y? Y is the distance from here. I should have made y clear. Y is the distance from load. What is y? Very important point. Distance from load. Distance from load. Now let's see something. If I am at load, if I am standing at load only, then what is the value of y? Y is equals to 0. At load, the value of y is equals to 0. Now what is my zy? Again, let's write down the formula. The formula is z naught into zl plus jz naught tan beta l divided by, it's not tan beta l, sorry, not l, y, because I am taking a random distance, no, a random distance from load. I'm not talking about the input. I'm taking a random distance from the load. So that's why I'm writing time y divided by z naught into, sorry, z naught plus jzl tan beta y. This is the formula. And what I'm putting, y equals to 0. If I put y equals to 0, what I will get? What will be the value of tan beta y? That will be equals to tan 0. So tan 0 is equals to 0 only. So this will be gone, this term will be gone. Z naught and Z naught will be cancelled. Basically, z at y equals to 0. What we are getting? Z naught into ZL plus, this will be 0 only, this will also be 0 only. So ZL plus 0 divided by Z naught plus 0. So what you are getting? Z at y equals to 0 is ZL only, and which is pretty obvious, right? At the load, you should have got the impedance to be equals to ZL only. This is pretty obvious. If you are at y equals to 0, your impedance is ZL only. But at a distance y from the load, your impedance is Z naught into ZL plus JZ naught tan beta y upon Z naught plus JZL tan beta y. Is that clear to you? Okay. Now if you are at the source, that means what will be your length? Y equals to L. That means you have covered y equals to L length. If you are at the source, if you are someone who is here. So a lot of time this impedance is shown as Z in. Okay. Because this is the complete input impedance of the transmission line, no? So sometimes this impedance is shown as Z in. So here, if I am saying I am at y equals to L, then the impedance will be called as Z in. So what will be the value of Z in now? Z in will be equals to Z naught into ZL plus JZ naught tan beta y equals to L I need to put, divided by Z naught plus JZL tan beta L. So usually this formula is taught everywhere, but no, this is not the case. They can ask the impedance on any point of the transmission line. It is not necessary that they will ask only at the input. I can ask here as well. Here as well I can ask. So you just need to know that how much away you are from the load. That will be your y value. So that y value you can put. Now we will take some special cases. Okay. So what we are doing, at a particular distance y from the load, we are writing down the impedance. Now let's just say this y is equals to odd multiple of lambda by 4. That means it could be lambda by 4, 3 lambda by 4, 5 lambda by 4, or any odd multiple of lambda by 4. Then first let me know the value. What will be the value of tan beta y? So that will be equals to tan beta. What is beta? 2 pi by lambda. And what is y? What is y? Let's just say y I am taking lambda by 4 only. For now I am taking y equals to lambda by 4. So what I am getting? This and this get cancelled. So what you are getting? Tan pi by 2. And what is the value of tan pi by 2? Infinity. Right? Tan pi by 2 is infinity. Say yes or no? Now, instead of lambda by 4, if I put 2n plus 1 lambda by 4, like it will not only work for lambda by 4, it will work for 2n plus lambda by 4. That means at any odd multiple of lambda by 4, it will work. So tan beta L I need to find. So what is the value of beta? 2 pi by lambda into 2n plus 1 lambda by 4. So lambda lambda got cancelled. So what you are getting? Tan 2n plus 1 into lambda lambda got cancelled into pi by 2. Now if I put n equals to 0, what I am getting? Tan pi by 2. If I put n equals to 1, what I am getting? Tan 3 pi by 2. If I put n equals to 2, what I am getting? Tan 5 pi by 2. Value of all these are infinity only. This is also infinity, this is also infinity, this is also infinity. All these are infinity only. Right? So what I am getting? I am getting infinity only. So tan beta y is infinity for with this particular case. So what will be my z at y equals to lambda by 4, or you can say z at y equals to 2n plus 1 lambda by 4. That will be z naught into zl plus j z naught tan whatever it is beta y divided by z naught plus j zl tan beta y, right? Now I know one thing. What do I know? That this term is very larger than zl. Tan beta y is already infinity, so this term is very larger than zl. So I can ignore zl, no? I can ignore the zl, and in the denominator I can ignore z naught because this term is very larger. So what I'm gonna do, in the upper side I'm gonna ignore zl, in the downward I'm gonna ignore z naught. So this z naught will be there as it is because that is in the multiply. This is in the plus. Like infinity plus anything will be infinity only, no? Right? So this is what I am doing. So this z naught remains there as it is. J z naught tan beta y divided by j zl tan beta y. So tan beta y is getting cancelled. J is getting cancelled. So what you are getting? Your impedance when your length is, that means the distance from the load is odd multiple of lambda by 4, then the impedance will be z naught square by zl. So whatever the load is there, it is inversely proportional to that load. Whatever the load is there, the impedance is inversely proportional to the load. The impedance at lambda by 4 will be inversely proportional to the load. In the upper side, what will come? Z naught square will come. And what is Z naught? Z naught is the characteristics impedance of the transmission line. So this should be there in your mind, and we will again and again use it. Eventually you are going to remember it. So what do you see here is that your zy is zy at lambda by 4 or at different odd multiple of lambda by 4, it is inversely proportional to zl. So just your zl is getting inverted. Let's just say here I was having short circuit. Short circuit means zl would have been equals to 0. If your load was shorted, that means zl would have been 0. Then what would be the impedance at lambda by 4? That would have been z naught square divided by 0, that means infinity. So if load was shorted, then at lambda by 4 you would get open circuit. If it was open circuit, then at lambda by 4 you would have got short circuit. If it was inductive, then at lambda by 4 you would have got capacitive. What do I mean? If your ZL was inductive, let's just say my ZL was some J5 ohm. This was my ZL. So at lambda by 4, at the distance lambda by 4 from the load, what I would be getting? Z naught square divided by J5. So this J goes upward. So minus J Z naught square by 5. So what is this quantity? This is capacitive only. So inductive becomes capacitive. Capacitive becomes inductive. Open circuit becomes short circuit. Short circuit becomes open circuit. So at lambda by 4, you are seeing a inversion, right? Whatever that was there at the load, at lambda by 4, you are just getting the opposite of that. A very important point, right? Now let's take the case of lambda by 2. So in the same manner, we can do the analysis. What will be the value of? And here I am taking any multiple of lambda by 2. Any multiple of lambda by 2 will work. So what will be the value of tan beta y? So tan beta 2 pi by lambda into n lambda by 2. Okay, lambda got cancelled. What we are getting? Tan n pi. And what is the value of tan n pi? That is 0. Even if you put n equals to 0, 1, 2, 3, 4, that is 0 only. So what do we get? What will be our formula? Y equals to n lambda by 2. The formula would be z naught into zl plus j z naught tan beta y, that is 0 only, divided by z naught plus j zl tan beta y, that is 0 only. So 0 0, this is gone, and z naught will get cancelled. What I am saying, zl into 0, that is 0, z naught into 0, that is 0. So what you are left with? Z naught into zl upon z naught. So what you are getting? Your impedance at lambda by 2 away from the load is equals to ZL only. That means if this is your transmission line, if this is my transmission line and here I am having any load ZL, now I start working on this transmission line. If I have worked for lambda by 4 distance, then there will be inversion. Basically, if I have worked for lambda by 4 distance, then there will be some inversion. That inversion would be Z0 square by ZL. But if I work for another lambda by 4, that means total if I work for lambda by 2, total if I have worked for lambda by 2, then the same expression I will be getting. That means after lambda by 2, the D2 same thing is repeated. And after every lambda by 2, this will be repeated. Basically, at lambda by 2 it is repeated, then at lambda also it will be repeated, at 3 lambda 2 by also it will be repeated, at 2 lambda it will be repeated, 5 lambda by 2 it will be repeated. And this is pretty obvious as well. Why is that so? Let's just say I am standing here. I am standing at this particular point. Now where will be this point? This point will be lambda by 4 away from this particular point. This point is lambda by 2 away from the load. I am calling this point as B. So this point B is lambda by 2 away from the load, but this point B is lambda by 4 away from point A, right? At point A, what is the impedance do you see? Z0 square by ZL. Now on the transmission line, if I have worked for lambda by 4, if I have worked for lambda by 4 on the transmission line from the load side, then what should be the impedance? The impedance should be Z0 square divided by whatever the impedance that I get here. Are you getting this point? What I am writing? I am writing down the impedance. I am writing down the impedance at point B. But this time I am not working from the load. This time I am working from the point A. From where I am working? I am working from the point A. So what will be the formula? If I work from the point A and I need to reach at the point B, that means I need to work for lambda by 4 distance. And when we work for the lambda by 4 distance, then this is the formula. Z0 square by ZL. So Z0 is the parameter of your transmission line divided by ZL. That means whatever the load you see at lambda by 4 distance, whatever the load you see, this load I see. So what is that load? Z0 square by ZL. So what you are getting? If you solve this, what you are getting? ZL only. So basically here your impedance is, at n lambda by 2 is proportional to ZL, no? So what is happening in the transmission line? Let's just say this is my load. This is my load. So at lambda by 4 there will be inversion. Then again from here to lambda by 4 again there will be inversion. So inversion, two inversion will make the same thing. Are you getting this point? ZL. Then after lambda by 4 there is inversion. Then again after the lambda by 4 there will be another inversion. So that means at lambda by 2, from the load at lambda by 2 you are getting the same thing. Is that clear to you or not? You started from here. After lambda by 2, you are getting the same D2 thing. A very good point. This is how you need to understand the impedance of transmission line. We just write down the formula and we write down the special cases. We don't even understand anything. But this is how you need to utilize. You just, the thing is, I am not gonna analyze with respect to only load. Now in the examination, what if I give you a transmission line and then I say that at a particular point in the transmission line, at any random point, I see the impedance of ZA. Then at lambda by 4 distance away from this particular point, what will be my impedance? Will you be able to write down? Yes. What will be the impedance? The impedance will be, sir, Z0 square divided by at lambda by 4 away, what we are seeing? ZA. That would be the answer. Because if I work for lambda by 4 in my transmission line, then my impedance will be changing by Z0 square divided by whatever the impedance that was there. That's it. So at any random point they can ask you the impedance. Usually they have always asked at the input, but it is not necessary in the examination. If they want to frame a good question, then they will frame these kind of questions that at a particular point they will give and then they will make you work. Are you getting this point? So let's write down the summary of all these points. Okay. So only till now, what all things you need to remember? Only two formula are there. Which formula? This one. That at lambda by 2 you will get the same impedance. At lambda by 4 you will get the inversion. Z0 square by ZL, and here you will get the ZL. And since we are applying this formula again and again, so you can remember this one as well. Because we are applying it again and again. So if you remember this one, then it will be also very good for you. Okay. So let's see the conclusion. So at lambda by 4 distance away from the load, what will be your impedance? Z1y I am writing. That would be Z0 square by ZL. Then lambda by 4 away, lambda by 4. That means total lambda by 2 away. This is your total lambda by 2 away. So without even deriving, I can write down. What I will say? That sir, Z2y will be equals to Z0 square divided by Z1y. Right? So what is by Z1y? Z1y is sir Z0 square by ZL. And if I solve it, what I am getting sir? Z2y is equals to ZL only. Or directly I have derived it as well. That at lambda by 4, at lambda by 2, at any multiple of lambda by 2, I will get ZL only. Now, from here to lambda by 4 away, from this particular point to lambda by 4 away, what will be the impedance? Z3y. So that would be Z0 square from here to lambda by 4, or you can say total 3 lambda by 4. Total 3 lambda by 4. So sir, from here to lambda by 4 away, if I need to write down Z3y, so what that would be sir? Z0 square divided by Z2y. Z0 square divided by Z2y, because from lambda by 4 there is always an inversion. So what I will get? What is my Z2y? That is ZL only. So Z0 square divided by ZL. There is another way of writing Z3y. What that would be? What do I know? After lambda by 2, there is the same thing repeated. If it was ZL here, here also it was ZL. So after lambda by 2, same thing is repeated. Now here if it is Z0 square by ZL, then after lambda by 2 the same thing will be repeated. That means the distance between these two guys is lambda by 2. So if you are getting Z0 square by ZL here, that means after lambda by 2 the same thing will be repeated here. So Z3y will simply be equals to Z1y. And what is that equivalent to? Z0 square by ZL. So now instead of mugging up the formula, are you understanding the concept now? That what is actually happening in the transmission line? Now from here to lambda by 2, you are getting this point. So whatever the impedance that you got here, the same impedance you will get here as well. So your Z4y will be equals to Z2y, and that will be equals to ZL only. Or you can say it will be the, what will be the total distance? The total distance from the load will be lambda. So it's not necessary that you will always do the analysis from the load. You can do the analysis from any random point to the next point. And this is what I'm going to teach you in the standing wave pattern as well. That will be the next topic. These are very important topics. So usually in EMFT, what happens is that people go with the formula. I'm not only talking about transmission line, I'm talking about the complete chapter. But this chapter is not dependent on formula. Those who have studied the comprehensive course, it is uploaded on YouTube only. Then you will realize that without understanding the formula, we can understand the concept as well. And this is the way we need to proceed. Is that clear to you? Okay. So now all things are clear. Just you understand one thing, that after every lambda by 4, the things are being inverted, and after every lambda by 2, the same things are repeated. Well and good. Let's go to other cases. Like this is not a special case. You don't need to remember the final result, but this is something that might be asked in the examination. Like it would be helpful for you. Okay. This is not a special case. Other cases it is. So no need to remember. Just see the analysis. So again, I need to write down ZY only. ZY I need to write down. So what is the value of y? Lambda by 8. So what will be the value of tan beta y? So tan beta y will be 2 pi by lambda into lambda by 8. So that will be 10 pi by 4. So here what is the value of 10 pi by 4 you are getting? That is 1 you are getting. Here the value you are getting 1. So what will be your z at y equals to lambda by 8? That will be equals to z0 into zl plus j z0 tan beta y, and that is 1 only, right? Divided by z0 plus j zl tan beta y, that is also 1 only. So this is what we are getting. So z equals to z at y equals to lambda by 8, you are getting z0 into zl plus j z0 upon z0 plus j zl. Now let me know one thing. This is the formula which you don't need to remember. I am just telling this analysis because this is famous. A lot of time the length in the examination will be given lambda by 8. Okay, it is famous, that's why I have written down the example. There is no other reason behind that. Because here tan pi by 4 is becoming 1. So calculation becomes a bit easier. That's why. But just let me know one thing. Is that true only for lambda by 8? No. It is true for lambda by 8. And after lambda by 2, everything is repeated. So lambda by 8 plus lambda by 2, or lambda by 8 plus lambda by 8 plus 3 lambda by 2. Basically, after every lambda by 2, things are being repeated. After every lambda by 2, things are being repeated. Lambda by 8 plus lambda. After every lambda by 2, things are being repeated. After every lambda by 2, things are being repeated. So this is true not only for lambda by 8. This is true for lambda by 8. Then if you add this thing, what you are going to get? 5 lambda by 8. If you add this thing as well, then what you are going to add? 9 lambda by 8. Here you can do the calculation. So in that manner, it is applicable. I guess it will be increasing by 4 only. So it should be 13. Yeah, 13 lambda by 8. 13 lambda by 8. 17 lambda by 8. 3 lambda, here it should be 2 lambda because it is increasing by lambda by 2. Yeah. So 17 lambda by 8. So it is applicable for all these points. Okay. 5 lambda by 8, 9 lambda by 8, 13 lambda by 8, 17 by lambda by 8. So it is applicable. This formula is applicable for all these points. Again, you don't need to remember it, but in the examination, sometimes these length can also be mentioned. So there it should be coming into your mind that there will be some very simple formula. Okay. Let's see this case as well. If my load is open circuited, here I am not talking about any length. I am taking another random length. So load is open circuited, that means ZL is infinity, right? So what will be my ZY? ZY is Z0 into ZL plus J Z0 tan beta Y upon Z0 plus J ZL tan beta Y. ZL is infinity. That means this load, this guy is very large. So I can ignore this guy. If my ZL is infinity, then this guy can go to 0. And if ZL is infinity, that means this guy is very large. That means this guy can go to 0. Right? So what I am left with? Z0 into ZL upon JZL tan beta Y. Okay? ZL get cancelled. So what we are getting? ZY. I should not write down ZY. I am writing Z open circuit Y. Z open circuit Y we are getting as minus J Z0. ZL get cancelled. Minus J Z0 cot beta Y. Again, it's not necessary to remember all these things. Okay? But these are the special cases. Any day you can derive in the examination as well. Very simple calculation it is. Just if you remember this formula, you will be able to get to this particular expression if it is required in the examination. Okay, same goes for short circuit as well. You can derive the same thing for short circuit as well. ZL is equals to 0. So put ZL equals to 0 in this expression. If you put ZL equals to 0 here, ZL equals to 0 here, then what will happen? Z0 will get cancelled. So what will be the formula you will be getting? So Z open circuit Y, open circuit expression will be equals to J Z0 tan beta Y. Okay, so this will be the expression that you will get. Again, I am writing now open circuit. Sorry, this is the case of short circuit. This is the case of short circuit. Sorry, this was the case of open circuit. That means ZL was infinity here. This is the case of short circuit. That means ZL is 0 here. So if I put ZL equals to 0 here, then what I am getting? Z0 get cancelled. So J Z0 tan beta Y I will get. Okay. So what you have got? Open circuit and short circuit. The formula for open circuit was minus J Z0 cot beta Y. And here for short circuit it was J Z0 tan beta Y. How do I remember? I remember that cot beta Y will be there, tan beta Y will be there. And with cot, usually we study tan. Cot we rarely study. So if I am writing down cot, that means there will be minus sign as well. So minus J Z0 cot beta Y and J Z0 tan beta Y. Now confusion will be, sir, which formula is for open circuit, which formula is for short circuit. So open circuit, it has O. And in cot as well there is O. Open circuit, CO. In tan there is no CO. But in open circuit and cot, open circuit and cot. So minus J Z0 cot beta Y, short circuit will be J Z0 tan beta Y. So this is how I remember because I have enough practice. But your examination is after 11 days only. So you might not be having enough practice. So you can derive it in the examination. Very easily you will be able to derive it. But if you are deriving it, that means you need to remember the formula of ZY. That is Z0 into ZL plus J Z0 tan beta Y upon Z0 plus J ZL tan beta Y. So this is the formula of ZY. At lambda by 4 length, what happens? Z0 square by ZL. And at lambda by 2 length, the same thing are repeated. So this is the conclusion of our 35-minute discussion. What is the conclusion? This all things are the conclusion. This is the conclusion, nothing else. And another conclusion is, after lambda by 4, things are being inverted, and after every lambda by 2, the things are getting same. This is the complete conclusion of last 35 minutes. And with that, you will be certainly able to solve 2 mark question in the examination. It can come for 1 mark as well, 2 mark as well, but certainly it will come. And in this 35 minutes of discussion, you will be able to solve that. Just see one of the solution from my side. Okay, this is a basic question. Then I will solve this problem. After that, you will solve all the problems on your own. And all these are gate PYQs only. Okay, all these problems you will solve. I will just solve this problem and this problem. After that, you can solve on your own. Now in the examination, let's just say this question comes up in front of you. You can see that this load is short circuited and they are asking Zin, and Zin is lambda by 4 away from the load. So here will you be thinking that, sir, what is the formula of Z open circuit, Z short circuit? No. What you will see? Lambda by 4. If lambda by 4 and lambda by 2 are coming, these are my priority. If lambda by 4 and lambda by 2 are coming, I just know that at lambda by 4 things will be inverted. So if I need to write down the impedance, so at lambda by 4 away from load, the transmission line could be anything. It could be this much larger as well. I need to write the impedance after lambda by 4. Whether it is input impedance or it is anything else, I don't care. But I need to write down the impedance after lambda by 4. That would be Z0 square by ZL. Z0 square divided by ZL, that is 0. So what I am getting? Infinity. That's it. But in the examination, if the length is lambda by 8, so now you will see that, sir, this is not a standard length. So better now I can go with Z open circuit formula, because this is not a standard length, lambda by 8. Lambda by 4 and lambda by 2 are the standard length, but lambda by 8 is not the standard length. So now I can go with the which formula? Now I can go with the formula of open circuit, because here you are having open circuit. Open circuit, quote, and quote we don't use usually, so that's why minus sign will be there. So J Z0 quote beta y, beta y. Then I will see the length. What is the length? J Z0 quote beta. What is the value of beta? 2 pi by lambda. And what is y? Y is lambda by 8. Lambda lambda gets cancelled. 2 pi by 8 is pi by 4. Quote pi by 4 is 1. Quote pi by 4 is 1. Look, 2 pi by 8. 2 pi by 8. This is very simple thing. Pi by 4. Quote pi by 4 is 1 only. So what I am getting? Z open circuit is minus J Z0. There you go. Z0 value will be mentioned in the examination. Okay. So answer will be minus J Z0. So here I did not think of that short circuit formula or open circuit formula, but here I thought of it because the length was not standard. In the examination, 99.999999% I am saying that length will be standard only. It could be lambda by 8, lambda by 4 or lambda by 2 or any multiple of that. Like in the examination, it might happen that they can give you the length of 5 lambda by 4. But you know that it is equivalent to lambda by 4 only, because it is odd multiple of lambda by 4. So I am saying 99.99% chances are there that from this particular, like till now, whatever the question has been framed, those questions have been framed on the same particular values. Okay. So let's see the gate PYQs. This is a gate PYQ only. You need to find the impedance here. So from where I will start solving? From here I will start solving. So first is this particular scenario. The length is lambda by 2. So if I write down the impedance here, between these two nodes, if I write down the impedance, what value I will get? 2 R naught. After lambda by 2 distance, it will be repeated. Say yes or no. And if I write down the impedance here, after lambda by 4 distance, R naught by 2, it will be inverted. So what will be the impedance? Z0 square by ZL. That means R naught square by ZL. That is R naught by 2. So what you are getting? 2 R naught. Are you getting this point? What I am solving, I am looking at this node. What is happening here? There is a transmission line. Then at the load of the transmission line, 2 transmission lines are connected. If I call this point as A and this point as B. So between point A and B, this transmission line is connected. If this point is A, then this point is also A. If this point is B, then this point is also B. So between A and B, there is one transmission line connected. Between A and B, there is another transmission line connected. So this transmission line at the input will give you this much impedance because it is lambda by 4. What is the formula? Z0 square by ZL. So R0 square divided by this R0 by 2. So what you are getting? 2R0. And here also what you will get at lambda by 2, same thing is repeated. So 2R0. So what you see here is that whatever the circuit is there, I don't care. But here you are having A and B. Here you are having A and B. Right? So between A and B you are getting 2R0. And between A and B you are getting 2R0. Between A and B you are getting 2R0. Between A and B you are getting 2R0. So what is the equivalent? 2R0 parallel with 2R0. What I am getting? R0 only. So now how my circuit is reduced? My circuit is reduced somewhat like this. This is my one transmission line having a length of lambda by 8. Having a length of lambda by 8. At the load, this point is A. If this point is A, that means this point is also A. This point is already B. So this is my load AB. And between AB, what is connected? R0 is connected. And what is the impedance of this line? That is R0 only. And what do you need to write down? Zin. So what will be my Zin for lambda by 8 length? You don't remember, you can derive it in the examination. But we have already written down the formula for lambda by 8. We just remember that for lambda by 8, tan beta y will be 1. For lambda by 8, my tan beta by y will be 1. This is what I remember. That my tan beta y, that will be 1. So what will be my Zin? Zin will be Z0. What is my Z0? R0. Z0 into ZL plus JZ0 upon Z0 into ZL plus JZ0 upon Z0 plus JZL. Basically ZL and Z0 both are equal now. Both are R0 only. ZL is also R0. Here my ZL is equals to R0 only and Z0 is also equals to R0 only. So this and this term is getting cancelled. So what is the value of Zin? Zin is equals to R0. That's it. That's the answer. This is the answer. Very simple. Input impedance looking from here is R0. This is not tough at all. You just need to keep on solving the transmission line. Try doing this question on your own. Try doing this question on your own. You would be able to do it, believe me guys. So this is one transmission line. From here I need to find the impedance. So first I need to keep on solving these lines. So between A and B, this transmission line is connected, which is having Z0 2. Between A and B, this transmission line is connected. This is having Z0 3 and load is 50 ohm, load is 50 ohm. Z0 2, Z0 3 both are 100 ohm only. The length is lambda by 4. This length is also lambda by 4. So what do you see between A and B? What all resistance you will see? So first resistance, let's just say it is coming from this transmission line. From transmission line 2, because here Z0 2 is there. So from transmission line 2, what will be the impedance? From transmission line 2, the impedance will be Z0 2 square by ZL. What I am saying, if I write down Zin 2, that would be Z0 2 square by ZL. Z0 2 square is 100 into 100 divided by 50. That would be equals to 200. So from here, looking at this side, I will get 200. Similarly, downward as well, the same circuit is there. The length is also same, load is also same, everything is ditto same. So here also you will get 200 ohm. Then again you will get 200 ohm only. So what will be the equivalent? 100 ohm. Right? So add the load between A and B, what do I see? 100 ohm. So what will be my Zin? So my Zin will be again at lambda by 4. Basically this is the scene now, that you are having your transmission line which is having a length of lambda by 4, and here you need to find out the impedance, and at the load you are having 200 ohm. 200 ohm, sorry, you are having 100 ohm because equivalent is 100 ohm only. Are you getting this point? So now you need to write down Zin. What will be your Zin? Zin will be Z0 1 square. What is the value of Z0 1 square? Z0 1 square. Z0 1 square divided by ZL, which is 100 only. So what is Z naught 1 square? 50 into 50 divided by 100. So what we are getting? Z in is equals to 25 ohm. That's the answer. Very, very simple thing. There is nothing here. There is nothing that can trouble you. Are you getting this point? Right? Lambda by 4, lambda by 4, lambda by 4. You just remember all the formula. If you are not able to solve this one on your own, then try doing this one on your own. This is a bit different actually. Here I can call this point as A and this point as B. So in between there is another point AC. So between AC there is this transmission line and between CB there is this transmission line. So how much impedance this guy will give you? CB. Lambda by 4 distance is there. So the impedance, let's just call it Z in 3. So Z naught square by ZL. 100 square by 100. So from here you will get 100 ohm. And what about from here? The length is lambda by 2. So after every lambda by 2, the same thing is repeated. After lambda by 2, the same load is repeated. What is the load? 100 ohm only. So between A and B, this is 100 ohm. And A, this is C. Okay. Between C and B, another 100 ohm is there. Between C and B, there is another 100 ohm. So this time they are not coming in parallel, they are coming in series. C and B. And then there is transmission line. This is your lambda by 4 length, 100 ohm, and you need to write down Z in. So what will be the total impedance? That would be 200 ohm, right? So what will be your Z in? That would be Z naught square by ZL. Because length is lambda by 4. Z naught square 100 into 100 divided by ZL, that will be 200 ohm, right? So what you are getting? 50 ohm. Not tough at all. Very easy question. Very smartly, very easily you can do these kind of problems. Are we having another problem? Yeah, this is also very easy only, but this is just another way of representing the transmission line. Till now we were representing our transmission line with 2 wires, right? We were representing it with 2 wires. But in the examination it might happen that they can represent it with 1 wire as well. Because downward it is symmetric only, no? Downward it is symmetric only. So sometimes they can represent it with 1 wire as well. So what do you think, what will your Z in? Length is lambda by 2. So what will be this impedance? Looking from here, length is lambda by 2. So the same 50 ohm will be repeated. So what will be your Z in? Here you are having 100 ohm. The same 50 ohm is repeated here. So here you are having 50 ohm. What they are asking? Z in. Z in will be 100 parallel with 50. So 100 into 50 divided by 150. That will be equals to 100 by 3 ohm. Okay, that's the answer. Very simple it was. It was just another way of representing the transmission line. That's why I asked you to solve this problem. Now solve this question. Magnitude of open circuit and short circuit impedance on transmission line are 100 ohm and 25 ohm respectively. Characteristics impedance of the transmission line. Think about it. Magnitude of open circuit and short circuit. What is your Z open circuit? That is J minus J Z naught cot beta L. And what is your Z short circuit? That is J Z naught tan beta L. Tan beta Y I can write down. Tan beta Y I can write down. If I multiply both of them, what I get? If I multiply both of them, Z open circuit into Z short circuit. J into minus J will be 1. Z naught into Z naught will be Z naught square. Tan beta Y into cot beta Y, what that would be? 1. J into minus J, 1. Z naught into Z naught square. Tan beta Y into cot beta Y into tan beta Y, 1. So what I am getting? Z naught is equals to under root Z open circuit into Z short circuit. So what will be the value of Z naught? They are asking the characteristics impedance. So 100 into 25. Okay. Whatever we get, 5 into 10, 50 ohm. 50 ohm. That's it. Now next concept is impedance matching. So I will teach this, but let me take a break because it's been 50 minutes. So you can just revise it. I don't think there is anything to revise. Okay, you can just revise it, and then I will restart. Okay, let me take a break now. Yeah, okay, so I am back. I hope you would have already revised whatever that we have studied. Okay, now there is one concept that is named as impedance matching. This is important as well, and this is very simple. So in transmission line, our target would always be to match this Z node to ZL. What is our target? That our Z node should be equals to ZL. Okay. Now why do we do so? So that you will understand in the next video. In the next video, where we study about standing wave pattern. So there you will understand why do I want to achieve this condition, that why I want Z node should be equals to ZL. But this is my target, that my Z node should be equals to ZL. But now let's just say by any means this ZL could be some coming from any further stages, and this Z node is also a parameter of a transmission line. So it might happen that Z node is not equals to ZL. So how I will make both of them equal? That I need to see. That is my target. That my target is that Z node and ZL should be equal. So for that, what I'm gonna do is that I will take this transmission line. I have this ZL as well. I have this transmission line as well. I have this transmission line of Z node characteristics impedance. I have the ZL as well. But what I'm gonna do is that in between I'm gonna insert another transmission line that has a characteristics impedance of Z node dash. Okay, and then I will connect the same ZL here. I will connect the same ZL here. I will keep the length of this transmission line. I will keep the length of this transmission line as odd multiple of lambda by 4. So what will be the minimum length? Minimum length will be lambda by 4. So length could go as lambda by 4, 3 lambda by 4, 5 lambda by 4. In that manner it can keep on going. So what did I say? I have a transmission line. I need to match ZL. What did I do? In between I inserted another transmission line having characteristic impedance of Z node dash. Now this Z node dash depends on me because I am gonna insert it. So let me know one thing. What will be the impedance here? The impedance here will be Z node dash square divided by ZL. And what is my target? My target is this Z node should be matched with the impedance that I look from here. This Z node should be matched with the impedance that I look from here. So this is my target. So what I need to do? That my Z node should be equals to Z node dash square divided by ZL. So what should be the value of Z node dash? So Z node dash should be Z node into ZL under root. There you go. So in the examination, what do they ask? They ask this thing. Or they can ask the length of the transmission line as well. They can ask the length of the transmission line as well. What would be the length? Lambda by 4, 3 lambda by 4, 5 lambda by 4. So whatever the option is mentioned, that you will pick. If they are asking the minimum one, then you will pick lambda by 4. If it is coming in MSQ, then lambda by 4 could be there, 3 lambda by 4 could be there, 5 lambda by 4 could be there. Okay. Or what they ask? The quarter wave transformer. So this is known as quarter wave. Why quarter wave? Because we are using the length to be odd multiple of lambda by 4. 1 by 4 is quarter. So quarter wave transformer. What it is known as? Quarter wave transformer. So the next question that they ask is, what should be the characteristics impedance of the quarter wave transformer? So that should be the geometric mean of Z node and ZL. Why that happens, like how we do it, that process is also clear to you, right? Z node should be matched to ZL. What did I do? In between I inserted another transmission line having Z node dash as characteristic impedance. My load is ZL. So input should be equals to Z node dash square by ZL. So Z node dash should be equals to under root Z node into ZL. So this kind of question can be asked in the examination. A load impedance of 200 ohm is to be matched with 50 ohm transmission line using quarter wave transformer. The characteristic impedance of quarter wave transformer is. So what should be the characteristic impedance? That should be the geometric mean of Z node into ZL. So what will be the answer? We will be getting 100 ohm. So that should be the answer. That's it. Now this is not the only way of doing the impedance matching. This was one of the way of doing the impedance matching. The other way is using stub. Now what is this stub? So what do we do? Let's just say I am having a transmission line. I am having a particular transmission line. So at any random distance from load, I will connect another transmission line. What I am doing, I am having a transmission line at any random distance from the load, I will connect another transmission line. I will connect another transmission line. Now the load of that transmission line, either it would be shorted or open circuited. What you are doing, from the load at a random distance, you are connecting another transmission line, and the load of that transmission line is either open circuited or short circuited. So that is known as stub. So this particular structure, this particular circuitry is known as stub. Okay. So what we will do then, we will find the equivalent of this one, and then we will try to match the equivalent of this one to this guy. How do we do that? That is not important for you. In the examination, what will happen? This circuitry will be given, and then they will ask you what all the impedance you can see, what kind of admittance you can see, these kind of questions they ask. Usually they ask impedance, but now what they are asking? They are asking you about the admittance. So what they have said, from the load at random distance lambda by 2, you have connected a stub. This will be written in the examination. So don't get confused with the name stub. What do you mean by stub? A transmission line where load is either open circuited or short circuited. So you have connected a stub which has a length of lambda by 8. This transmission line is having a characteristic impedance of Z0. This transmission line is having a characteristic impedance of Z0. That value is 50 ohm. What you need to find? You need to find the admittance looking from here. So at this particular point, this is A, this is B. So AB will see two kind of transmission line. One is this one, other one is this one. So if we work, let's first find out that what will be the impedance because of this transmission line. AB will see two kind of transmission line. One is stub, another one is this one. So at lambda by 2 distance, what will happen? The same ZL will be repeated. So at AB, what do I see? At AB, wait a second, कौन message कर रहा है भाई इतने? At AB, I see 100 ohm. Why 100 ohm? Because after lambda by 2, everything is repeated. Now, what about lambda by 8? So what do I know for lambda by 8? For lambda by 8, I just know that my tan beta y will be 1. Tan beta y will be 1. And this is short circuit load. Short circuit load. So what will be the formula? That would be J Z0 tan beta y. Are you getting this point? First thing I will see is that this is short circuit. This is shorted. And for shorted, I have a certain formula, that is J Z0 tan beta y. And since the length is lambda by 8, so for lambda by 8, I know that my tan beta y will be 1. So what I am getting? Z short circuited is J Z0. Z0 is 50 ohm. So at AB, one I see J 50 ohm and another one I see is 100 ohm. J 50 ohm. Okay. So from here, I need you to find the admittance they are asking. But can I write down the impedance? Yes. What will be the impedance? That's our impedance will be 1 by Z. If I say what will be the impedance? So impedance will be 1 by Z equals to 1 by 100 ohm plus 1 by J50. 1 by Z equals to 1 by 100 ohm plus 1 by J50. What is 1 by Z? 1 by Z is Y. 1 by Z is Y only. So 1 by 100. What is 1 by 100? 0.01. And what is 1 by 50? What is 1 by J? That is minus J. And what is 1 by 50? 0.02. So whenever they ask you the admittance in the examination, always write down the formula. Let's just say there is this circuitry R1, R2, R3. And they ask you from here what will be the admittance. If they ask you the resistance, if they ask you the impedance, then you will be very comfortable. But what if I ask you the admittance? So do nothing but write down the formula of parallel impedances. What is the formula? 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R equivalent. Okay. You write down the formula, then what will be your 1 by R equivalent equals to? So 1 by R equivalent will be equals to your Y equivalent. So there you go. So that answer will be 1 by R1 plus 1 by R2 plus 1 by R3. So usually what people does is that first they will find Z equivalent, then they will take the reciprocal. But no, go with the basics. 1 by R equivalent to 1 by R1 plus 1 by R2 plus 1 by R3. That's why I picked this question, so that I can tell you this concept of network analysis as well. Whenever they ask the admittance, then rather than going by finding Z equivalent, go with the basics. First thing, that your 1 by Z equivalent will be equals to 1 by Z1 plus 1 by Z2, and 1 by Z equivalent is equals to Y. So from there 0.01 minus J 0.02, very easily you are getting. Otherwise I would have gone into complex calculation, but that calculation I need to avoid. So how will I avoid that calculation? That I have told you. So that would be the answer. This would be the value of Y. So how you are doing the impedance matching, that you don't need to care about. Just in the examination they will ask you these kind of questions, then you should be able to solve. So this will be the last question of our topic, and if you are able to solve this one, then you are good to go. You will be able to solve the problem in the examination, 100% I am telling you. Okay, and yeah, this was considered as a decent question. It came in gate 121, so this was considered as a decent question. So try doing it. What they are doing, there are two stubs. This stub has a length of lambda by 2. If the length of lambda by 2 is there, that means open circuit will be replaced with open circuit only. This is here open circuit. So at lambda by 2, what will happen? Open circuit will be replaced with open circuit only. And what is this? This length is lambda by 4. So short circuit will be replaced with open circuit. Are you getting this point? Here the length is lambda by 4. Here the length is lambda by 2. So they have connected two stubs here. But those two stubs are of no use. The user connected two stubs, but both are of no use. Why is that so? Because this is the length of lambda by 2. Open circuit will be replaced with open circuit. This is the length of lambda by 4. Short circuit will be replaced with open circuit. So what is your equivalent circuit now? In your equivalent final circuit, what do you see? This is my point P. This is my point Q. P, Q. Here Z naught was 50 ohm. Then I am having a length of lambda by 4. And then at the load I am having ZL. And this your Z is 75 ohm. Right? This ZL value I need to know such that impedance matching is there. So what I will do? Here I am using lambda by 4 quarter wave transformer. So here he is using both kind of impedance matching. Quarter wave transformer as well, and stub matching as well. But stubs were of no use. So what will be the impedance he will be getting here? Let's just call it ZX. That will be Z naught square by ZL. And that should be equals to Z naught, which is your 50 ohm. So ZL would be 75 into 75 divided by 50. Did you get this point? Our target is that this transmission line should be matched with whatever the impedance it sees at PQ. So what impedance it is seeing at PQ? Z naught square by ZL. So 75 into 75 divided by ZL should be equals to 50 ohm. So what ZL you are getting? 75 into 75 divided by 50. So 112.5 ohm. There you go. Almost we have done all the PYQs. Not all the PYQs, like roughly you will be now, if the question is coming from this particular topic, which I feel it will come, then you will be able to solve certainly in the examination. So this was our first topic. The next topic is standing wave pattern on transmission line. So I will try to keep this video short only because MOSFET video went for 3 hours. If I include that particular topic which we say standing wave pattern, then it will go for 3 hours as well. So first you need to study this particular topic, then you can go to the standing wave pattern. So I will upload this video today itself. I guess it is 7 PM. So I will try to upload it by 8 PM so you can watch it. And tomorrow we will go to standing wave pattern on transmission line. This is also very, very important, and very good questions can be framed from this particular topic. And a lot of guys who have studied it, you can ask anyone who have studied EMFT from anywhere. He will say the toughest topic is this one only, because he mugs up the formula here. But without even using any single formula, without even using any harsh equation, without even using those equations, we are going to solve these kind of problems. Okay. So certainly we will meet in the next lecture. We will talk about what do you mean by traveling wave, what do you mean by standing wave. All these topics we will talk about. So till that, you revise this 1 hour of lecture. I guess in 1 hour of lecture, everything is clear. And let me know in the comment section that how you are finding this kind of initiative, because this is a bit different initiative that we are, without even starting the chapter, we are right going in between of a particular topic and covering that from scratch without even knowing the previous thing. So I tried to bring something different because rest all the initiatives are already coming on other channel. So the same initiative I never wanted to bring. I wanted to bring something different because you can certainly follow their lecture as well. They are also doing good thing. So if I bring the same thing, that means that will be of no use. No, I tried to bring something different because these are the high yield topics and certainly the question would be coming from here. So if someone who has skipped this, then at least you should have a clear idea, like basic idea or more than basic idea you are getting. Like, I should not say this, but in 90% of the comprehensive course, you will not get this idea. This is just one video. This is not even comprehensive course, okay? But in 90% of the comprehensive courses, you are not even getting this idea. So here it is crash course of crash course. This is not even crash course. This is crash course of crash course. So in that as well, you are getting a decent idea, and certainly you will be able to solve the problem in the examination. So next, our video will be on standing wave pattern on transmission line. Thank you very much. Happy learning.